I want to talk a little bit about reserved words in C++, naming conventions, so that means the names you give to your functions and variables, and I want to end with namespaces. Now, listing a long list of reserved words is bad practice, I think, but I'm going to do it anyway, so you have a somewhat of an overview of the reserved words that exist in C++. Now you have to know that reserved words are words you cannot use for names for your functions or your variables. They are reserved. Let me show you. Now I've shown them here in Word. I'll make them a little bit bigger. These are some of them, and you can see for some they were introduced in C++ 11. Some will be introduced in C++ 20. But it's quite a list. You can see some of them we already know. Float, and I'm sure int is there. So just have a browse through them, and this is the entire list. For now, of course, in the future this list will change. Maybe some words will even disappear, although that's unlikely. But it is likely that new names will be added. Now, you won't have to memorize these words, because if you use a good IDE, it will warn you when you try to use a reserved word for something that you can't use it for. As an example, I see the word goto here. Let's see if I can make a variable called goto and what will happen. So if I made a function here, int main, as you know, our main function, and I make an int and I call it goto. You see, it's immediately turned a different color because my IDE recognizes it as a reserved word, and it puts a little squiggly line below it saying that it expects an identifier, and officially this is not an identifier because it's a reserved word. If I just call it I, it'll turn a different color again, and it will be recognized as an identifier and a local variable. But really, if someone else were reading my code and they saw this, it wouldn't have any meaning. Now, generally, the name I is used for an int that is only used temporarily to count something or to be locally in a loop or whatever. But the name I in itself doesn't really mean anything. It would be better if I called it counter, right? Or if I were making a game, a lives counter. See, this is a lot more verbose, and it sort of documents my code. If anyone were to read this code 10 years after, they would know that this variable would hold the number of lives. There are things to say for naming your variables. Some compilers reserve all variable names that start with an underscore. That is entirely up to the compiler to check and to notify you about. Some compilers don't allow a name with 2 underscores in a row anywhere in the name. Now, there's such a thing as camel casing. The name of this identifier basically exists of, it's 2 words. It's lives and counter. So camel casing means leaving the first word with a lowercase letter, and the second word gets an uppercase letter. If this were the lives counter of an enemy, I could call it this, lives counter enemy. Now, it's probably not smart to make the identifier names too long, because if you're going to do arithmetic on them or some test, the actual functions or the expressions that you write will be very, very long, and that will actually diminish the readability of your code. There's also something to be said for working in the type of the variable. As you know, every variable in C++ must have a type. And sometimes it's smart to start the name of the variable with an I to indicate that it is an integer. You could even separate the name from the type by adding an underscore. Now, this may seem like a little much, And your IDE may even help to tell you what kind of type this is. But if you're somewhere in your code and your functions are really long and you come across a variable, then it may be handy to indicate what kind of type you want the thing to be. Now, this doesn't add any functionality. It's purely for readability. Now, this thing is also important. If I were to write a function that was called increase lives, and it would have a parameter called lives. And what it would do, it would increase the number of lives and then return it. Simple enough. But here's the thing. Inside this function, the variable lives points to the name of this one. And in some cases, this can be a little bit confusing because if you're looking at this code, it may not always be clear which variable this is. So any parameter, you could precede with a P to indicate that you're dealing with a parameter. Now again, this is all optional. I mean, I've known people who name all their variables just a single character, like X. And this works just as well. The compiler doesn't really mind as long as the names are unique. But someone who reads your code, which may be you in a couple of years, would like to know a little bit more about the semantics of what you've written. Semantics are really the meaning of the variables and the functions that you introduce. So now that we've talked a little bit more about how variables and functions are named, there's something that has started to occur a little while after programming became mainstream. What I mean by that is that these days, any program that does anything significant probably isn't built with the bare language. It can be, but it's most likely that you'll be using libraries. And that was the whole reason for writing code in such a way that it can be reused. That's been a mantra for programmers for years. Write reusable code. Make libraries so that others can use your code so they don't have to write everything again. You don't want to reinvent the wheel if it's already been invented. Now, along the way, we've been using more and more libraries, and these libraries have been built by different people. And there was nothing to say that the variables and function names that they use in their libraries shouldn't match. Now, what I mean by that, I'll make a little drawing. So suppose I wrote a program which used two libraries. One library for graphics and one library for sound. Now, both of these libraries have a function called vol. In the graphics library, it means something to do with volumetric lighting, for example. In the sound library, obviously, it would have to do something with volume. Now, if I used the function vol in my own program, the compiler wouldn't know which vol to use. And this is a real problem. I'd have to indicate specifically which one I'd have to use. So if this one was called sound somehow, and this was called graph somehow, I could actually indicate which vol to use. Now this is where namespaces come in. Because in this case, if I wanted to use the sound one, I could say sound vol, or I could say graph vol, and it would be perfectly clear to the compiler which function I was actually using. Now, how does this work in C++? In C++, there's a keyword called namespace, and it introduces a namespace. And a namespace encapsulates all the functions and variables inside it to this namespace so that others can refer to the namespace and then the variable. Now, a namespace is introduced quite simply by typing in namespace and then these two brackets. Now, I should call my namespace something logical, usually the name of my library. So any variable in this namespace that I introduce can now be referenced to using this sound name. So if I typed in int, how about volume? I would now have a volume variable inside the sound namespace. Now, if I wrote a program that used this namespace as well, I could type in the following. I could say using namespace sound. So if I now typed in volume and I set it to 2, it would be now clear to the compiler which volume I would be referring to. There's something else I could do. I could also type using sound volume, and any reference to the variable called volume would now be interpreted as a reference to the sound one. Now, when you're starting C++ programming like we are, you immediately run into this issue or this feature of the language because C++ uses the standard namespace, std. And when we write a small program that outputs something like hello to the screen, we're immediately confronted with the fact that cout and endl reference the standard namespace. That's why at the start of the code, you usually see using namespace std. And now you understand what that does, because if it encounters a function called cout or an identifier called endl, it'll look in the standard namespace and see what it means. We could have also written this. So this way, we're not saying that we're using the namespace std, but we're explicitly saying that for this function cout and this thing endl, we want to take them from the std namespace. Now, if we have to do this every time we use cout, it's going to be a little tedious, so that's why we use the using namespace std at the start of the code. This doesn't solve all our problems, because if there was another library which also uses cout or endl or anything inside the standard namespace, we would still have a problem recognizing which one we meant. Now, in terms of std and cout and endl, we could have also used this. So this way, we will always use the cout from the std namespace and the endl. And then throughout our code, when we use this, we know which one we mean. But in our sound and volume example, where two libraries have the same names, we would have to be condemned to indicate which volume we wanted to use most of the time. Well, like I said, namespaces are not unique to C++. You will see them in any modern language. They've been added to many, if not all, of the languages, and all because of the same problem. We all use libraries, and we don't know that the names that they use inside the libraries are all unique. So that's all you need to know about namespaces. I hope you liked it. I'll see you next time. Bye-bye.